Alright, so today what we're going to be doing is we're going to be showing you all how we operate 3D printers in the 3D printing lab here at Auburn. So we're going to get started with setting up a print, that way it can be printing while we're talking about some of the examples. So what we do to set up a print is we take a SolidWorks part file or any solid part file, we slice it up in a special slicing software for, like for example, these German machines come with their own proprietary software. There we set all of the print settings, stuff like infill density, layer height, print temperature, so like bed and nozzle temperature, and then we take it over to each of these machines on a USB, plug the USB in, find the file in the machine's internal memory, and then we hit start. So the first thing that we do is we always glue up the build tray. This just helps the part stick to the build tray and also helps us to get the part off, that way we're not trying to scrape a part off of glass. So what we do is in the printer screen, we can find the part file, we can do any last minute changes to temperature that we need, and then we hit start. Now what the machine is going to do is it's going to go through, heat up the print bed and heat up the nozzle, and if you can watch it here, it's going to check the leveling of the build tray. So it's going to go around to different spots on the build tray and then run it up to a sensor on the print gantry and see if the print is level or not. So while that's doing its own thing, over here we have several examples of the different print parameters they can set. So one of the main print parameters they can set for 3D printing is something called infill density. So a part like this is never truly solid during 3D printing. You have all these empty spaces in this hatch pattern that you see here. So what infill density represents is the amount of empty space to amount of space occupied by material. So here is two examples. So in the image here, or in the part right here, we have 20% infill density. So it has 20% of the volume of the part is filled with material, whereas 80% is empty air. And this part right here, this is 0% infill density or 100% free space. So there's none of that hatching pattern to be seen here. Another option that we have is something called layer height, which is how far or how small each layer is when the printer is printing. So when the printer is printing, like what you can see in this guy over here, is the head's going to move around and deposit material, but whenever a layer is finished, the build plate is going to move down by some increment. That increment is known as layer height, and that's what we set in the print parameters. Now, besides what's called FDM 3D printing, which is what these technologies are, where you have a spool of material that feeds into the print head and is deposited on the build plates, there's another technology called resin 3D printing, or SLA, DLP, any of those printing types, which uses a vat of photosensitive resin and will create the part layer by layer in a similar fashion, but at a much lower layer height. So whereas these printers that are printing right now will print 0.1 micron or 0.1 millimeter, 0.2 millimeter layer heights, resin printing usually goes 200 or 25 micron, 50 micron layer heights. So it's, an order of magnitude finer. One other interesting thing that we do down here is we've been experimenting with trying to do multicolor 3D printing, like with this Obby face, where we stop the printer at specific layer heights, change filament, and then we can achieve a multicolored effect. What we also do is, this is specifically for the final project for the introduction mechanical class, is we try and print, or we do print, the brackets that each group designs. So the objective of each group is to try and make a bracket that is both lighter and stronger than some original design. We 3D print their brackets and then we break their brackets and see who did the best. So those are a couple examples there. One other really cool but niche application of 3D printing is creation of lithopanes, like what this light box is right here. So what you can do with 3D printing is you can take a 2D image and then turn it into a 3D object. And by varying the thickness of your 3D object, you can achieve different light gradients, like with this image right here. So you can create a 3D image or you can create a 3D object from a 2D image.